Hello everyone, my name is Muhammad Ikhwan Khozairi bin Muhammad Khairi. I'm gonna to tell you about AC and DC motor. I will tell you about its different types and how they work. So let's begin.
Okay, I will tell you about the types of AC motor and DC motors. But first, we begin it with the types of AC motor. Firstly, we have synchronous AC motor. Second, we have induction AC motors. But for induction, they have two types. First, single phase induction AC motors, and secondly, three phase induction AC motors. Okay. I'm gonna tell you about synchronous motor. Okay, look at the picture. We have DC supply. We have three phase supply. From the picture, we can know that an AC motor is in steady state, and it contains multi-phase AC electromagnets on the stator of the motor, it is three-phase supply. The rotor in a synchronous motor is mostly of sodium pole type, and DC supply is given to the rotor winding via slip rings. How synchronous motor works? Okay, the stator is one for the similar number of poles as that of rotor and fed with three-phase AC supply. The rotor winding is fed with DC supply which magnetizes the rotor. The rotor is rotated up to the synchronous speed of the stator by means of an external force, and the rotor field is excited near the synchronous speed. The poles of stator will keep attracting the opposite poles of the rotor. So the rotor will undergo unidirectional torque, and the opposite poles of the stator and rotor will get locked with each other, and the rotor will rotate at the synchronous speed. Okay, now I will tell you about the induction motor. An induction motor is a motor with only amortisseur windings, and induction motors works on the principle of induction where electromagnetic field is induced into the rotor when rotating magnetic field of stator cuts the stationary rotor, and it has two types. Firstly, single phase, and secondly, three phase. How single phase induction motor works? Okay, it is the picture for single phase, and it is, we must remember that it is not self-starting. The main winding carries an alternating current. The start winding can have a series capacitor and a centrifugal switch. When the supply voltage is applied, current in the main winding lags the supply voltage because of the main winding impedance of current in the start winding leads the supply voltage depending on the starting mechanism impedance. The angle between the two windings is sufficient phase difference to provide a rotating magnetic field to produce a starting torque. The point when the motor reaches 70% to 80% of synchronous speed, a centrifugal switch on the motor shaft opens and disconnects the starting windings. For three-phase induction, when the motor is excited with its supply, three-phase stator winding produces a rotating magnetic field with 120 displacement at constant magnitude which rotates at synchronous speed. This changing magnetic field cuts the rotor conductors and induces a current in them according to the principle of Faraday's law of electromagnetic induction. As these rotor conductors are shorted, the current starts to flow through these conductors. For three-phase, we can also use the Lorentz force principle and Lenz law principle. And what I can conclude for these types of motor, the relative speed between the stator field and the rotor conductors causes to rotate the rotor in a particular direction. Hence, for producing the rotation, the rotor speed must always be less than the stator field speed, and the difference between these two parameters depends on the load on the motor. For DC motors, they have two types. Firstly, separately excited, and secondly, self-excited. And for self-excited, we have three types. Firstly, series, secondly, shunt, and thirdly, compound. For self-excited, the difference between them is how is the about the arrangement of the DC motors in the circuit in a circuit. For separately excited DC motor, separately excited motor have separated field windings, means supply to armature is different and supply to field is different. So any change in armature current has no effect on field current. Direction of rotation of motor can be reversed by reversing voltage. It can operate base speed. Armature is the rotatory part and field winding is stationary part. Motor is stationary part. Motor speed can be constant by varying armature voltage or by varying field voltage control. So, speed control of separately excited DC motor is good. Okay, for self-excited DC motor for series, field winding and the armature winding are connected in series so that the current that pass through external circuit and through field windings passes from armature as shown in the figure. That's why we call it series, because field winding and the armature is connected in series. The field coil of series wool generator has low resistance, consists of a few turns of thick wire. If the load resistance decreases, then current flows increase. As a result, magnetic field and output voltage increases in the circuit. In such type, generator output voltage varies steadily with respect to the load current, which is not required in most of the application. For shunt, field winding has many numbers of turns for the desired height resistance so that fewer armature current can pass through field winding and the remaining pass through load. Current in the parallel branch are independent of each other. The output voltage almost constant, and if it varies, then it varies inversely with respect to load current. This is because of the voltage drop as armature resistance increases. For compound one generator is advanced version of series one generator and shunt one generator. It have two types in the compound. It has both types of winding series and shunt field winding. And in compound we have long shunt compound and short shunt compound. The armature voltage decreases automatically when load current increases, due to which magnetic field produced by shunt winding decreases. But the same increase in load current flows to the series winding causes an increase in magnetic field. So, the magnetic field in the shunt field is decreases, which is compensated by increasing magnetic field in series field. Okay, that's all from me. Thank you very much for hearing about my explanation.
Now that you know about different types of motor and how they work, I will talk about their applications and how to control them. For DC motors, the selection of DC motor are based on three aspects, which is starting, speed control, and braking. Starting means how fast can the motor be brought to its operating speed, while the operating speed itself should be maintained as the requirements of the load. This is also called speed control. Finally, the machine has to be brought to rest by decelerating. This is called braking. For series DC motor applications, it is used where high starting torque is required and variations in speed are possible. Some of the examples for series motor are in traction system, cranes, air compressor, vacuum cleaning, and sewing machine. For shunt DC motors, they are used where constant speed is required and starting conditions are not severe. The various applications of DC motors are in lathe machine, centrifugal pumps, fans, blowers, conveyor belts, lift, and etc. For compound DC motor application, It is used where higher starting torque and fairly constant speed is required. The example of compound motors are presses, shears, conveyors, elevators, rolling mills, and heavy planers. There are two controllable parameters of a DC motor, which is direction and speed. To control the direction, the polarity of the motor can be reversed, and to control the speed, the input voltage is changed. Next, for AC motors, each of these motors have their own unique features. For synchronous motors, they are known for their efficiency in maintaining the power of the overall system and can also be used as stepper motors. They find their major application in areas where accuracy is important. The example for synchronous motors is in clocks, timers, electromechanical robots, metering pumps, speed controllers, and high-precision drill machines. For induction motors, they are efficient and flexible, which allow them to match the load demand for almost any type of application. They are mainly used in water pumps, kitchen appliances, fans and air conditioners, automobiles, and common industrial machineries. Next, for linear motors, they produce a linear power to push or pull an object. This happens because of their flat and spread out structure in contrast to other AC motors. They are widely used in ground-based rails, monorails, magnetic levitation lines, roller coasters, and similar transportation machinery. Next, for universal motors, they can be operated on both alternate current and direct current, but their important features is their constant high rotary speed. This is useful in applications like railway, drill machines, kitchen blenders, vacuum cleaners, and dryers. For adjustable speed motors, the motors can change their speed by switching the numbers of poles contained within. This feature gives them application in marine and land machinery, electrical power plants, cargo pumps, and water cooling equipment. In general, these motors are used in all systems and processes where automatic switching of rotor speed is required. To control AC motors, it is much harder compared to DC motors. The speed reduction of an induction motor can be accompanied by a loss of efficiency and poor power factor, but the efficiency can be changed by changing the supply voltage of the motor, the stator pole numbers of the motor, and the frequency of the supply side of the motor. It can also be changed by adding an external resistance into the rotor side circuit.
Hello everyone, my name is Muhammad Afifuddin bin Amar and I'm going to talk about AC motor versus DC motor. AC motor versus DC motor. First, we will take a look at AC motor. AC motor works on AC power supply. AC motor needs starting mechanism for single phase only. Its supply system can either be single phase or three phase. AC motors do not have brushes and commutator. It is very rigged and has long life expectancy. We can control the speed of AC motor by changing its frequency. AC motor is less efficient because of induction current loss and motor slip. AC motor require less maintenance because of absence of brushes and commutators. Next, DC motor. DC motor works on DC power supply. DC motor is self-starting. It only has single-phase supply system. DC motor has brushes and commutator which limit the speed of the motor and reduce its life expectancy. We can control the speed of DC motor by changing armature's winding current. DC motor is more efficient since no motor slip and induction current loss occur. Unlike AC motor, DC motor demands extensive maintenance. There are several advantages and disadvantages for each motor if it is used over the other. If DC motor is used, the advantage is that it has higher starting torque. DC, mo DC motor have a starting torque as high as 500% compared to normal operating torque. Other than that, it has wide range of speed control. The attractive feature of DC motor is that it offers the wide range of speed control both, both above and below the rated speed. The disadvantage of DC motor is that it requires a lot of space compared to AC motor for same capacity. This is due to cross-sectional area of conductor in DC motor that it is required more than AC motor. Another disadvantage is that it requires high maintenance. Care is required to maintain the mechanical interface used to get current to the rotating field. AC motor advantage includes lower power demand on start and minimal maintenance. Other than that, its torque characteristic is very close to the ideal characteristics. Torque of AC motor is constant up to a certain speed and then decrease compared to DC motor torque that linearly decrease as speed increase. The disadvantages of AC motor is the inability to operate at low speed. We know that standard AC motor should not be operated at speed less than one-third of the base speed. This is due to the thermal consideration. Other than that, poor positioning control. Last, AC motor produce eddy current. This is because motors are generators that operate in reverse. They produce EMF just like generators do, and it is called back EMF. Back EMF works to reduce the current in the loop, thus slowing the motor down. That's all from me. Thank you.